Hi, I'm Nick McCrory. I'm a new technology integration architect for IBM. And as an IBMer, it's always been a sense of pride for me to see the work that IBM does with the various sporting events that we host and manage. The US Opens, the Australian Open, the Masters, as well as some of the other events that we do on the internet. So today I'd like to talk to one of our teammates on the continuous availability team, Aaron Brockman, who is one of the masterminds behind the predictive cloud computing. Aaron, hello.
Thanks a lot. It's a pleasure to be here and to present some of my views about advanced analytics. In particular, talk about some of the work that's been happening within the predictive cloud computing space that is in support of a lot of the various events that we host. We do professional golf and professional tennis, such as Australian Open, the Masters, USGA, Roland Garros. So it's neat that we get live streaming data. And we have the opportunity to showcase some of these technologies. So thanks for having me.
Oh, absolutely. And we also eat our own cooking. We do a lot of work internally. We also host IBM.com, correct?
Yeah, we do. We do have a lot of premier services that we provide, right? And so a lot of our continuous availability services, they not only support golf and tennis or worldwide sports, right? But we also support platinum services such as IBM.com. Right, and so we host that, and so simultaneously at the same time that we host these events. Oh, and by the way, we also have some entertainment venues as well, such as the Tony Awards that we work with as well.
And we're using analytics to advance our capability for continuous availability in what ways? And what are we talking about when we say advanced analytics to start with?
Yeah, so that's a great question because it depends on who you ask, right? If you were to ask someone, if they, in theory, could shout from the surface of the earth, their name, travel faster than 350 meters a second, land on the moon, and then hear that same shout, did they travel back in time, right, to hear that shout? Well, that's up to the person whom you ask, right? And with respect to advanced analytics, it's much the same. It's very similar, right? From my perspective, advanced analytics really, it combines various fields together, statistics, machine learning, probability distribution functions, software development, right? So it's quite fun to be there at this time. In particular, within the advanced analytics space for the advanced infrastructure, we're using a continuum of advanced analytics, right? So we can start from the descriptive space, right, where we basically say how many of what. Right, so we want to find descriptive type techniques that can aggregate, averages together, counts together, right? Then as you go up in complexity, you also go up in competitive advantage, right? So as we go up to what's called the predictive analytics space, where you might have things such as decision trees, you might have neural networks, you might have logistic regression, any kind of probability distribution function, right? That helps you classify, or it can even be a regressor, such as a polynomial regressor. And we use that to help us predict what's going to happen in the future. And in sports, there's so much uncertainty that happens, right? I mean, for example, last night, which was May the 13th, we had the Wizards play NBA basketball at the same time as the Capitals and hockey, and it's quite a sobering night because both teams lost, right? So I am a fan of both, right? But they lost because of various reasons, right, that were unpredictable, right? And so in golf and tennis, we use these types of predictive algorithms, and then going up in complexity, the final bin, if you will, would be the prescriptive, where you get into a lot of the operations research area, where you might look at genetic algorithms, which tells you how you want to fine-tune a particular decision variable so that you can optimize a certain problem that's defined by an objective function, right? Some other, we do use some genetic algorithms. We had an Extreme Blue project called Cloud DNA that used a genetic algorithm. Within our predictive cloud computing system, which we'll get to in a minute, we use what's called power optimization techniques, which is a numerical analysis method, right? And it helps us to anneal out of local maximas and to find the best Pareto optimal solution for a problem. So it's quite neat. And then there's other methods within operations research, such as Monte Carlo optimization, which is quite popular. And So to me, that's sort of what advanced analytics is about, is distilling a whole bunch of information into knowledge and insights.
Yeah, now that's a whole lot of information just to get started with. So let's try to think of some real world examples of the different types of analytics you talk about. For example, what would you use prescriptive analytics to accomplish?
Okay, so prescriptive, right? You might say, how do I create a container or we'll say an IHS, which is a IBM sort of Apache front end web server. How do I configure that appropriately? There are over 100 different types of parameters of which you could configure, which could be amount of memory you want to use, the number of threads, the response time, right? So if I can encode that into a algorithm, into a prescriptive type algorithm, then the algorithm will run, right? And my objective function tells it what it should aim for, what target should it try to achieve. Is it response times? The number of users of which it should support, etc. Right? And then it comes out and it will tell you how to set each one of those 100 parameters, so that we can say, how do we create that container? And that's one example.
Is it using sort of like previous log data to do this? Is it using real-time data feed?
Right. Yeah. So in this case, right, we would use simulation, right, where we would each epoch we would simulate real traffic that hits our web server, and then measure our objective function to figure out which set of parameters are performing better, and then figure out how do we cross over or mutate the parameters such that we get better and better and better until we finally converge to our solution, and then we can output that prescriptive type plan that we need to follow.
Yeah, I was reading the paper that you have upcoming to be published on the subject, and one of the things that fascinated me the most was the fact that you're running simulations in real time, well, actually to predict the future during the events, and that again just sparked my sci-fi cool factor.
Yeah.
So, what about predictive analytics? I mean, how would you use what is the usefulness of predictive analytics in what you do?
Yeah. Okay. So with predictive analytics, right? We use it today where we combine a whole lot of different streams of data, right? So we'll take Twitter data, we'll take scores, from real events that are happening, golf and tennis events. We'll take schedules, we'll take weather information, and then we also take machine logs that are scattered across our machines and virtual machines that are accessed, right? And we basically combine all of that into a pretty predictive model. So in a nutshell, we have to take out the most important features from each one of those data sources. And let's say in golf, right, for the Masters, you have the aim in corner. So if Tiger Woods is playing at one of the aim in corner holes, then perhaps we're going to have a spike in demand for our cloud services. So we want to go ahead and extract the features to figure out who is playing where. But in this case, we simulate forward so that we can create a future state space and then extract who's going to play where in the future, and then know, okay, Tiger Woods is going to be playing, say for example, hole on 12, right, in 4 hours. So therefore, we can predict in 4 hours that we're going to need this number of containers or capacity to support that, right? So that's one example of looking at the schedule. But we also monitor, as I said before, Twitter data, right? So we look at social sentiment and figure out how many tweets are about a particular player, also how many tweets are about just the tournament itself, and we look at the acceleration, the velocity, various things like kurtosis and skew, of the different types of data that are coming in, and those become what are called predictors into that predictive model, so that we can then in turn take all of that, input it into that equation, and then it outputs what the popularity is going to be that corresponds to the demand for the web server. So it's pretty cool about all these different techniques that are combined and used. And speaking of which, we do have a good number of patents that have been filed around this area too.
Well, that was one of the things I was going to ask you about. Actually, you just hit two things, so we'll go with that first. Are you using any out-of-the-box products, or is this very high level of customization, or a combination of the two?
Yeah, so it's a combination. Okay, so let me just rattle off some of the products that we use, right? I think that might be helpful. We build some of our models offline, right? We don't do online training right now, right? So we use SPSS Modeler and SPSS Statistics to build our model. We also use InfoSphere streams to connect to GNIP as well as to pull in some of our logs from RabbitMQ. We also use InfoSphere Big Insights, which is built on top of Hadoop, to crunch a lot of our data at rest, where we can apply some of our deep advanced analytics. We just moved to Liberty, right? So we use WebSphere Liberty Profile, which is great because we can just quickly spin up our applications. We use an open source that's called Unstructured Information Management Architecture. It's a mouthful, but it's called UEMA. Actually, Watson, the original Watson that compete on Jeopardy, runs on that as well. But we use that to distribute out processes. We use what else? ActiveMQ for message passing. So that's sort of out of the box products that we customize. Some of the algorithms that we wrote, right? We have a lot of custom forecasters that are written in Java. We have an ensemble of time series forecaster. There's about 5 of them, I believe. Yeah, there's a partial forecaster. There's a average forecaster. There's a cubic forecaster. There is also a quadratic. We have a residual forecaster. So there's more than 5 actually. If you look at the paper, it details it out a bit, but that's custom written. We have a lot of curve matching that's custom written. Pretty much, I would say most of the algorithms, are pretty much custom written, but then they're wrapped around into products, right? And the fuel to all this is data, because you have to have the data. Like in the 20th century, the hydrocarbons were quite popular. Now it's big data. Data is the next natural resource that we have to process.
And one of the things I've been wondering about is are different sources of data more beneficial? I mean, have you found things that you were monitoring that you found really didn't add any value, or things that you started monitoring and were surprised at how much value they added?
Yeah. So that's actually very, very interesting that you asked, because since we do have so much different types of data, we do measure the predictive value of each one of the features that we extract, and found that in some cases, I can't say all, right? Because it's always dangerous to say a blanket statement that this is always better or most important. But in some cases, right, I say that the log data that comes from machines is extremely high predictive value. Whenever we talk about the prescriptive type analytics, it's the various streaming data that we get about the event itself. You could almost call those domain dependent, right? So whenever we get scores, stats, about the real-time game that's happening, the tournament that's happening, then that also is important. If we're talking about simulation, then the most important data there is going to be we could go down that rabbit hole, right? But there's different types of simulations that we run. But of course, the score information is very important, and weather data is also important.
Well, again, is there a big difference in the type of event? Because I'm thinking, number one, the user base or the viewer base for golf and tennis, there's some overlap, but they're very different. And also just the way the demand for the video resources and the multimedia resources that you're serving up, would really be driven by how many people are interested in the event. So, say in golf, you know who's coming to the amen corner. You're going to have people in the amen corner the whole all day, so you get cameras there. But likewise, in a tennis match, you've got cameras that are pretty much stationary. They don't have to move around. But in tennis, you can have a situation where, especially in a major, where someone's gone past the 5th set, or a match has gone past the 5th set, and it's 2 players who no one's ever heard of, or very few people have ever heard of, except for tennis aficionados, who might not have any real chance of winning the tournament. So you wouldn't really planned for this tournament, for this match, to have such a huge huge viewership. And I guess I'm just wondering if you see different value for different data sources based on the type of event you're hosting.
Yeah, certainly. I mean, one of the the big impetus behind this project was in 2012. It was the Australian Open where Nadal was playing against Djokovic, right? And the match just kept going on and on and on and on, right? I mean, it pretty much broke the record. It was over, what, 5.5 hours or so.
Wow.
Right? Yeah, so I mean, when you have that kind of match, then the traffic was exponentially increasing, because the longer it goes, the more that people want to watch it, and then the more it's viral, right? Where in the news media, people are talking about it, Twitter, people are talking about it, right? And so they want to come see it. And so because of that, right, Twitter was very important at that point in time to predict what was going to happen. So within an event, the predictors do change as far as what data is most important based upon what is actually happening during that event. Between golf and tennis, yes, some of the key areas that are the most different would be the simulator, right? Because the games are different. I could argue that the golf simulator is very complex, because you have to deal with shotgun starts, you have to deal with perhaps rainy weather more often than you do in tennis, because in tennis you have the domes that can close. Golf, I've never seen 18 holes where you can cover up 18 holes and play indoor, right? But so weather is definitely more extreme, I think, than golf, right? So with that, within golf, I think that the logs are potentially more important than tennis, whereas Twitter data is potentially more important in tennis than it is golf, because in golf you rely more on the game state information, whereas in tennis you rely on more about Twitter and logs, and a bit about who's playing at what point in time.
Well, are there any types of analytics? Well, we talked a lot about descriptive, and actually we didn't talk much about descriptive. We talked about prescriptive as well as predictive. Are there any other types of analytics that we really should hit on?
Yeah. We do show a dashboard, and we give tours, right? So we've had over 7,000, potential clients, executives, and such go through and look at our what we call our Watson dashboard. Or it can also be called our predictive cloud computing dashboard. And there, we show a lot of different counts, because people always come in and they want to know, so who is going to be playing where, or how many people are visiting the site at a precise time, right? So we aggregate those counts and we show them in real time as it's happening. And we also have spark lines that also show, general averages as far as, how many messages are being passed, in the system, how many algorithms are running in the system. We also show how many people are going to be accessing our tournament site. And we found that some of the venue staff will actually come in and they'll look at our predictive schedule, or we call it our predicted pace of play, and it'll tell them, where is Djokovic going to be playing, in 2 hours, so that they can plan as far as, foot traffic. So that's neat whenever they go and actually just look at. So we sort of unpeel that data onion, so people can get a better understanding and a better view as far as what's happening under the covers, both within the cloud, but also domain dependent for themselves, right?
Well, yeah, and that's, one of the things I've also been trying to get my mind around is how we could extrapolate this technology for other industries. Is there something, or can you tell me if there's any particular industries that you think are, best, or really best suited for taking advantage of this technology?
Yeah, sure. So let's talk a bit about impact. What is the impact of this work, right? So I want to mention that this work, right? We just came back from the Franz Edelman competition, and that's an advanced analytics, grand competition where they basically pick 6 projects from around the world, and you go in front of a judge panel, and they rank, you based upon your impact within the field as well as your innovation within technology. And so we were, the runners-up there, and I think part of that was because of our impact, right? We're able to save 51% of computing hours, which is, substantial.
Wow.
Right. Yeah. Yeah. So we're talking, it's roughly around 140 hours a day of computing that we can save whenever you apply this predictive type system because we're not maximally creating containers. We're doing it dynamically, both on an event based and a cyclical based. And then from a IP perspective, right, we have 17 patents around this area, right, and so that also has helped. From a monetary perspective, very crudely, we could save around well, just in the EI alone, we save $2.5 million a year within the EI itself. Now, where can this be used? What is the transportability? Well, it can be used pretty much anywhere, right? If you imagine, Amazon, right, during their holiday rush, um, sometimes you might notice their site could be sort of laggy, um, and that could be due to the fact that they have not provisioned enough services to handle the demand of all the shoppers, right? If they could
Well,
predict that, yeah, go
well,
ahead.
Well, that was one of the things I did think of was that during the retail season, particularly during Christmas, for instance, weather feed would be hugely important because you could tell if it was going to be raining in a particular area, more people might not go to the mall; they might shop online instead, or something like that.
Perfect. Yeah. Precisely, because those would be some of the predictors that we would extract, right? Right. We would connect over to the real time data feeds, maybe even put a deep thunder, right, and then get the weather prediction for a certain variant of time period, so that we could in turn make adjustments in real time. And what's also neat, right, is with this smarter energy, smarter planet area, right? There's this company called PDAM in Bandung, Indonesia, right? And they want to be able to predict water demand. So they supply water to their entire city. If they could predict how much water and when people would need it, then they could optimize the flow of water within their pipes. And so this system could be taken off of just the cloud itself and be put on top of the water infrastructure, right? And so that's another use case where this type of system could be used.
Wow. Yeah. Well, I mean, I've seen a lot of comparisons between network flows and water flows, certainly. Um, I've also seen things in, say, in the transportation industry. Again, not just from not necessarily airlines too much, but maybe trains, certainly, so that you'll see more demand based on things like weather as well as combined with holidays. Again, can you think of any other industries that that we could really focus on this?
Yeah, I mean, you could even think about healthcare, right? Because healthcare, is a burgeoning area for us right now, especially with the Watson Healthcare Group that was announced, right? Where if you want to predict traffic for let's say ER workers or an ambulance even, right? Then you could certainly help and predict what's going to happen, giving factors input into a not only just a predictive model but a prescriptive model, because that prescriptive model you would have decision variables that would be output, and it would tell you uh, the route of which you could take, perhaps the payload within the ambulance that you would want, and maybe even if you could support more than just one emergency that's happening, right? And so it's almost like trying to solve the Hamiltonian path problem, right? With this, and once you have those different types of variables that have been determined, then you could take that descriptive model and actualize that, and you could see some impact within healthcare.
Well, and we talked about the high level of customization that we've used in our events. Now, are we taking that kind of information and trying to create more standardized packages so that we can move from where we've grown from into a more commercial area?
Right. Yeah. So it's been fascinating, because this started out first of all as an Extreme Blue project, where we had pretty much 4 interns who worked with us, and they helped to start out the project, and then that moved over, and we needed to then harden the code so that we in turn could deploy this onto a continuous available, well, let's step back and let's say a highly available service, right? We want 99.999% of availability, right? And so once we go there, then we need to make sure all the code is hardened so that we get all the bugs ironed out. And so in that process, right, we have looked at using Google Guava libraries, which helps insulate us from some of the more complex code, if you will. On the deployment side, we just started using Urban Code Deploy, which is fantastic because that enables us to basically push a button where we push a button and we can deploy streams, we can deploy big insights, we can deploy our Liberty, right? We can also move a lot of the data around with it. We can configure our database schemas with just a push of a button. And we support 3 environments, what's called our event command and control, which is our dev/test. And then we have a Plex 1 and Plex 3, right? And so we're able to leverage and basically configure that. We also have a continuous integration with Jenkins, which is a continuous build tool. So that pulls from our Git repository, which is our software development repository, and it runs Maven build tasks for us. And then it pushes some of the completed artifacts over into Urban Code Deploy, which then in turn, it can automatically, or it can be scheduled, or it can be driven by a human to deploy to our cloud, right? And so we've matured that over time and really have, again, hammered out lots of bugs so that we could package it up and commercialize this product into a service offering or product offering.
So we are ready for prime time. That's excellent, and we'll have links posted along with this video to where to get more information. So we're basically at the end of our time. Thanks, Aaron, for talking with me, and hopefully we'll get to talk again.
Sure. Thank you so much for having me, and I also appreciate your time.
All right, thanks, man.